Okay, so the final equation we're going to do in today's presentation, you've got some nasty fractional powers. So you've got an equation in W. You've got two problems. The first problem, I'd say you've got these horrible power of a half and power of a quarter. Second problem is it's not really things aren't where you want it. So, but we can solve both of these things. We can do a U substitution and we can rearrange to form a quadratic in U. So we're going to let U equal, if we let U equal W to the quarter, so U squared is going to be W to the quarter squared. If you know your index powers, that's going to be 2, 4, so it equals W to the 2 over 4, which is W to the half, right? So this W to the half is going to end up being U squared, and this is going to be U here, right? So your quadratic you're going to have U squared equals 4U minus 2, and then you're going to move everything over to the other side, and you're going to have U squared minus 4U plus 2 equals 0, which looks really, really friendly. And you might think, right, I'm going to try and factorize this. And you've only got two options really. You've got a 2 and a 1, or a 1 and a 2, right? In fact, what am I even talking about? You've got a 2 and a 1. You're not going to get a 4 with a 2 and a 1. So actually this thing does not factorize. So don't mess about with it, looking at it for long. Once something doesn't factorize, go straight to the formula. So U equals, so minus B plus or minus, I'll write that down, minus B plus or minus the square root B squared minus 4AC all over 2A. So U squared, so U equals minus B, or B is minus, so B is minus 4, so it's minus 4, plus or minus the square root of B is minus 4, so minus 4 squared minus 4 times A is 1 and C is 2. All over 2A, 2 times 1. Tidy it up, so U equals, so minus 4 is just 4, plus or minus, so you've got 16 minus 8. 16 minus 8 is 8. Root 8 all over 2. So U equals 4 over 2 plus or minus root 8 over 2. Now what I might do here is turn that root 8 into something nice. So you recall that root 8 equals root 4 times 2 equals root 4 times root 2 equals 2 root 2. Right, so U equal, or 4 over 2 is 2. 2 plus or minus, which is 2 root 2, is the root 8 over 2. These disappear. So U equals 2 plus or minus root 2. So U equals 2 minus root 2, or U equals 2 plus root 2. I'm not going to check these just because it's going to be really, really hard. The question didn't actually ask us to. It's going to be pretty nasty, but what I will do, I'll leave it in the next slides, the part of the book where they actually use a GDC to check. But it's not a perfect check there, you just use decimal numbers. Anyway, I'm sure it'll be fine. Right, so we've got the two answers for U. You've got U equals 2 minus root 2, U equals 2 plus root 2. But do not forget that the question was asking about W. And remember that the substitution was U equal W to the power of a quarter. Right, so if we want to solve this thing for W, it's not going to look great, but essentially if U equals 2 minus root 2, then W to the power of a quarter equals 2 minus root 2, which would mean that W equals 2 minus root 2 to the power 4, which is horrible, and I really don't want to actually do that. So for this example, I'm actually just going to leave it in that form. For the other one, if u equaled 2 plus root 2, the other one would be, or w would equal 2 plus to the power 4. So, and this is why you could, in this equation, I've spoken a lot about checking the solutions. Now, these are not easy. They're not easy to expand to get them in a nice form without the binomial expansions, which we haven't covered yet. They're not very easy to substitute into and check if they work. If they work in the initial equation, it's just I'm just going to leave them like that. But I will put in the following slides a way you can do a little approximate check, certainly to 3 significant figures at least, with the GDC. So I'll make sure I leave that in the following slides.